Understanding the differences between CPUs and GPUs is crucial for machine learning, ML, because it directly impacts ML projects' efficiency, cost, and scalability. Here's a beginner-friendly explanation. CPU, or Central Processing Unit, is often referred to as the brain of a computer. CPUs are designed for general-purpose computing tasks. They excel at sequential processing, meaning they handle tasks one after another. CPUs are great for managing complex instructions, running operating systems, and executing tasks that require precision and reliability, such as database queries or code compilation. GPU, or Graphics Processing Unit, was initially designed for graphics rendering. GPUs have evolved to become powerful tools for parallel processing. They are optimized for handling many tasks simultaneously, making them ideal for compute-intensive applications like machine learning and deep learning. Imagine a head chef in a restaurant who must ensure all dishes are prepared perfectly. The chef can handle multiple tasks but does them sequentially. This is like a CPU handling various tasks one by one. Now imagine the head chef has many junior assistants. Each assistant can perform a simple task, like flipping burgers, simultaneously. This is akin to a GPU, where thousands of cores work together to perform many tasks at once. Think of a CPU as a single worker on an assembly line who completes each step of a product's assembly one after another. This worker is very skilled but can only do one task at a time. In contrast, a GPU is like having hundreds of workers on the assembly line, each handling a specific part of the product simultaneously. This results in much faster production. Let's look at CPU and GPU in the machine learning context. Machine learning involves training models on large data sets, which requires processing vast amounts of data quickly. Here's how CPUs and GPUs differ in this context. CPUs can handle smaller machine learning tasks or the initial stages of data preparation. However, they become inefficient when dealing with large data sets because they process tasks sequentially. GPUs are ideal for machine learning because they can process many data points in parallel. This significantly speeds up tasks like neural network training, making GPUs essential for deep learning applications. Imagine you're training a neural network to recognize images. Each image needs to be analyzed for various features like edges and colors. A CPU would analyze each image one by one, checking each feature sequentially. A GPU, however, can analyze many images simultaneously, checking multiple features at once across all images. This parallel processing capability makes GPUs much faster for such tasks. In summary, CPUs are great for tasks that require precision and sequential processing, while GPUs excel at parallel tasks, making them perfect for machine learning and deep learning applications.